Hi and welcome to video 4 this series on networks and graphs, Unit 4, Topic 3. So you can see the learning goal there, and in this video I'm going to talk to you about bipartite graphs and how we use those to assign and create assignments, basically is what they're called. I've got an example here. I did try and I have tried as much as I can to come up with my own examples, but my brain wasn't working at the time, and I've come up with stealing the example from Cambridge, the textbook. So you've got this in your textbook as well, but it's a good example. It shows 4 different teachers and 4 different instruments that they can teach. And so this is a bipartite graph. It connects 2 individual sets of information, and so you can see how that graph does that. In this case, what it's connecting is each teacher to the instrument that they can teach. So to devise a timetable here, we'd look at it and we'd determine a simple path to follow. If I'm following this path, there's a couple of ways I can start, but I've set up the 1, 2, 3, 4 here, and the 2 obvious ways to start are either who can teach the piano or who can teach the violin. So we started the violin, and the violin must be David. He's the only person who can teach violin, so we pop David down in here, and he's now gone. But what this means, well, for the piano now, we've got piano, and that must be Bronwyn. So we can see that she's the only one that can teach piano. Leaving us as 2 teachers. Who must teach the guitar? Well, the guitar is this one here, and you can see the guitar links to David and Adriana, and David's already gone, he's teaching violin, so that must be Adriana, and that leaves us with Celia teaching the flute. Spell her name there, and Celia on the flute. So there we've created an assignment. It's a unique assignment because we're able to pass through this bipartite graph without ever having to make a choice. It's a unique assignment, and so there's no other possible way of doing it in this case. So let's have a look at an example. Below some information, this is one I did make up, and it creates an interesting result. That's why I deliberately made it up. And it's about 7 netballers and then creating a team. So this is my loose understanding of netball, but I do know that these positions exist, and I do know that people would certainly probably train within groups of positions. So I'm going to start by creating a bipartite graph, and I'm going to do it by, and I've done that obvious cheat here where I've got people's names starting with A, B, C, D, E, F and G, and then I've got the positions: goalkeeper, goal defense, wing defense, center, wing attack, goal attack, and goal shoot. I've always liked the symmetry of a netball team. So now Amity can do either goalkeeper or goal shooter. Now things do get a little bit messy here, particularly because I've made it quite small. So let's zoom in a little bit. And that is my understanding, because she's maybe tall, although she has that skill set that would suit her. Brendan's a bit of a hog, and he's just going center, but obviously that's the person who tends to run around the most. Clay, he could do center as well, but he could also do wing attack or goal attack. So he's done some training in the attack areas, so I'll put it under there. Doovie can do wing defense or wing attack, so put a line to wing attack, a line to wing defense. Egbert can do goal defense or wing defense, so goal defense or wing defense. Let's get a bit out of hand now. Fiona can do wing attack, goal shooter. And Garibaldi can do goalkeeper or goal defense. So he's packed right up the top, which is frustrating. There it is, a little bit out of hand. Hopefully you can draw it a bit bigger or a bit neater. And sometimes a good solution is to just separate the lines a little bit more, will help spread it out a little bit more. Anyway, this is going to be my assignment. I'm going to have Brendan will be my center, because he can only do that. So I'll cross out Brendan, I'll cross out center. Now that obviously means that Clay can't be center. So Clay can now only be wing attack or goal attack. And I'm left with multiples. So Brendan is the only person who can only do one thing, and even though I cut him out and therefore Clay out of the center position, I'm left with multiple options, which means that straight away I don't have a unique solution. So I've got Brendan's definitely center, and then I've got solution 1. Let's put Clay This is where I have to make a decision. Let's put Clay at wing attack. And if I put Clay at wing attack, that means that, so he's not goal attack. Fiona must be goal attack to make this work. And if Fiona is goal attack, she's not goal shooter, which means Amity must be goal shooter. And if Amity is not goal shooter, she's not goalkeeper, which means Geribaldi is goalkeeper. Which means Egbert is goal defence. And that means that Doovie is wing defence. And solution 2 kind of goes the other way. Solution 2, I've got Clay being goal attack. And if Clay is goal attack, which means he's, so I'll rub all these out, apart from the ones that I know. Means that Fiona is not goal attack and he's not wing attack, and I'm actually left with another choice, so I could split 2 up again. So this would be 2 part 0.1, and you can see that I can build that second solution. So I might just leave that out. Here's a solution. It turns out there are 3 possible solutions now. I shoot down to say Fiona and I let her be wing attack out and not goal shooter and go through, or I do it the other way around and I let her be goal shooter and not wing attack, and they will work. So that's one way of setting up a bipartite graph and an assignment from that graph, depending on the complexity of the information you have. How many possible assignments are there? So in this case, maybe you got a chance to collaborate, maybe you didn't, maybe you just watched the video, but there are 3 possible assignments. What things are definitely true? Well, the only thing that's definitely true is that Brendan has to be centre. What connections could be removed in this context? Well, the only one that's obvious to me is that Clay can never be centre because Brendan's being a bit of a hog. If Clay was centre, Brendan's restricted to be in an untrained position. And we're obviously making this assumption here that they have to be playing in a trained position. So we could remove that centre position. And then the only other person I'd look closely at is Fiona. She's the only one left that's got 3 possible options, but in our 3 solutions she actually uses those 3 possible options once each. So they can all stay, but it's definitely worth checking. Okay, so I'll just put down here the answer is Clay and centre can be removed, otherwise the rest have to stay. Here's another example from the AQA exam board in the UK again, but I'll put this one down as a simple familiar. Decision Maths 1, June 2016. Alfred has bought 6 different chocolate bars. He wants to give a chocolate bar to each of his 6 friends. The table gives the names of his friends and indicates which of Alfred's 6 chocolate bars they like. So you can see this is alphabetical. He's got nice alphabetical friends again. Draw a bipartite graph. So I'm going to do part A here, and I've got Flavio, Garnier, Harry, Imogen, Jenny and Kim. And over here I've got the chocolate bars. So I've got coffee, nut, oops, that looks like a W, nut, lemon, mint, orange and plain. And I'm going to connect these across. So Flavio is happy to have, I might just show you another technique here, it's different colours. Flavio is happy to have coffee or nut. Garnier is happy to have lemon or mint. Harry is happy to have lemon, mint or orange. I should have done that in orange, right? Imogen is happy to have mint, and we can already see a restriction here. Jenny is happy to have nut or plain. And Kim is happy to have orange or plain. So this is, Imogen has completely ruined it, and quite selfishly she said she'll only have one of them, and so therefore when it gets to part B, that's going to be a restriction we're tied in with. So that's our first 2 marks. Part B, Alfred makes an initial matching with his friends and the chocolate bar they will each receive. Explain why Flavio cannot have the nut bar and find a more appropriate allocation. So I can already see, based on the information that we had, Imogen has to have the mint, and Garnier's got it. So that's a bit of a problem. But the question states it as, explain why Flavio cannot have the nut bar. So think about it like this. So let's start with the nut. Flavio has the nut. Now let's have a close look through this list and think about what's missing here. And the answer is, if Flavio has the nut bar, well, who's going to have the coffee? Who has the C bar? So that's our issue. And so the solution here to the first part, Flavio cannot have the nut bar because he's the only one that will have the coffee bar. So of course our answer is that we connect Flavio to coffee, which means coffee is done, Flavio is done. Flavio won't have the nut, which means nut can only be had by Jenny. So Jenny and the nut bar, which means Jenny's done, nut's done, Jenny's done. Jenny won't have P, which means Kim has to have P, the plain. So Kim's done, plain's done. Kim won't have orange, which means Harry has to have orange. Orange and Harry's done. Lemon, Harry's not having lemon, so that means Garnier has to have lemon. Lemon, Garnier's gone, and of course Imogen, we always knew she had to have the mint. And so that works. It's a unique solution because at no point did we have to make a choice. And it fixes up Alfred's initial matching, which was incorrect. So there you go, that's a pretty simple familiar question once you understand the process that we're working through. Okay, so you're on 11B, you can do questions 1 to 3 now. In our next video we're going to talk about the Hungarian algorithm. All the best.